Okay, what do you guys, we're going to start off with parallel lines. What do you know about parallel lines? They're two or more lines that never intersect, right? And so I did my very best to draw two lines that don't intersect, but they will because they're not perfect. But you get the idea. Now, you notice that I have line CD, and I gave the equation, and I graphed it. And I also gave line AB with the equation and graphed it. And those two lines are parallel. Now, again, maybe your lines look a little more parallel than mine. But can anyone tell me what the relationship between parallel lines and their equations? There's something critical about their equations and the fact that they're parallel. So look at the equations. If you're not looking up here, you're not doing what you're supposed to. Look up there. What do you know about these equations that help me to know that they are parallel?
They're in slope-intercept form.
Okay, they're in slope-intercept form, which is good review. But what about the equation itself tells me, hey, these lines are parallel? Mandy?
They both have the same slope.
Mandy.
They have the same slope.
They have the same slope. What's the slope of line CD? Negative 1/2. What's the slope of line AB? Negative 1/2. Now, do you notice they both have the same slope, but do they have the same y-intercept? No. If two lines have the same slope but different y-intercepts, they are automatically parallel. So do you have to graph it to know that? No, but does the graph help me out with that? Okay, how did I graph, this is review, how did I graph line CD? Where did I start? Where do you think I started? At 5 on the y-axis. 1, 2, 3, 4, 5, right here. And then what was my slope? Negative 1/2. So I went down 1 over 2, down 1 over 2, and I got line CD. Where did I start? Line AB, the green line. I started at 2 on the y, and then I went down 1 over 2, down 1 over 2, and I got line AB. And are they parallel? I hope so. So here's an important fact. Parallel lines have the same slope, but different y-intercepts. You need to know that. I'd write it down. You may begin now. Yeah, parallel lines have the same slope, but different y-intercepts. That's super important. Okay, write these two equations down, and we're going to answer the question, are these two equations, are they parallel lines? Well, what's the slope of the first line? What's the slope of the first line? Anyone know? Okay, the slope of this line is negative 1/2. Okay, great. How do you know so quickly that was negative 1/2? Yeah, y equals mx plus b. What's m? Negative 1/2. That's our slope. Great. What's the slope of this line?
1, 2. There's no slope.
Sorry, this line?
Oh.
Okay, we're guessing, right? Are there ways to figure out for sure? What form is this in? Standard form. You could find it from standard form, but that's that shortcut negative a over b. What's another way to figure it out? If you get this into y equals mx plus b. So I'm going to solve for y.
It's negative 1.
Yeah, but we didn't know that. We were guessing. So here we have, divide both sides by 2. You get y equals negative 1/2 x plus 3. So what's the slope of that line? The slope of that line was negative 1/2. Does anyone remember how to do it with the negative a over b? Standard form? I didn't have to do all that work. What's a? 1. What's the opposite of a? Negative 1. What's b? So negative 1/2. So I could see that from standard form, or I can work it out and get slope-intercept form. Okay? That's review. That's not new stuff, how to get this into slope-intercept, or even how to find the slope. So are these two lines parallel? Yes, even if I didn't graph them. Okay. Let's look at this. I wrote this in a special way because I want to get you more used to seeing geometric descriptions. Okay, can anyone read what that means? What is that? EG, not just EG. Line EG. The equation of line EG is 6x minus 2y equals 4. What is this? How do you read this right here? Line GH, and the equation is y equals negative 3x plus 8. Are these two lines parallel? How do you figure out if they're parallel? You have to find the slope. So I don't know EG slope, but I do know GH's. What's GH's? Negative 3. Negative 3. I got it from right here. It's y equals mx plus b. What about EG's slope? How did you find it, and what is it? So how did you find it, Cole?
It's negative 3 because you do the negative a over b.
So negative 6 over negative 2 would be 3. So what's your slope? Are they parallel? No, they are not parallel. Did they look like they might have almost been parallel? Yeah, because they both have a 3. But is the slope of 3 and the slope of negative 3, are those the same? No. So you say not parallel. Not parallel for these. But you have to back it up by saying what the slopes are, because then that's what you're comparing. Okay? They have to be the exact same thing. Okay? You guys good on that? It's pretty simple. I think it's pretty straightforward. Yes, ma'am?
For line G,
Oh.
could you do the same thing you did for...
Solve for y?
No.
Or sorry, this
I
one?
mean, yeah. Couldn't you just do 1/3 over 1? Like you did in the other one?
No, this is slope-intercept form, so they already gave me the slope. If it was in standard, yeah, I could do the same thing. Okay, oh my. Given J, and then the coordinate, K coordinate, L coordinate, and M coordinate is blah, 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 blah. Does anyone know how to read this for me? What does this mean? It's all this gibberish and symbols and stuff. Laura, try it out. Just this little part right here. This part right here.
Okay. Just read it.
Yep.
Line JK
Good. Line JK
is parallel
to.
line LM.
Okay, so I'm trying to ask, is line JK parallel? This little symbol right here, what do you think it means? Parallel, right? They're two parallel lines. Is line JK parallel to line LM? You're going to see that a lot in geometry, so get used to it. So that's our question. Is JK parallel to LM? I don't know. How do you figure it out? All they gave me was a bunch of points.
Graph it.
You can graph it. It's going to take you a long time. You may be inaccurate. But there's a way to... You could do point slope. You can make it easier in your life, though, if you did... Jack?
Find the slope of y sub 2 minus 1.
Yeah, just use the JK points and find the slope of this line. How do you find the slope of that line? You do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Of these 2 points, right? Line JK. That's how I picked JK. So what's y sub 2 in JK? 1. What's y sub 1? So it's 1 minus negative 2, which you can figure that out. And then what's x sub 2? Negative 4. What's x sub 1? Negative 4 again. And 3 over 0. It's a suspicious line. Wait, what does that equal to? What's 3 over 0?
3.
No.
That's undefined.
No. Undefined. Undefined. So far I have undefined. So this problem's over, right? Because one's an undefined. It's impossible to have a parallel line. Okay, I have undefined. So I'm like, what kind of line does that have to be? What's an undefined slope? Sarah? Vertical. It's a vertical line. Okay, so what's the only other type of line that could be parallel to a vertical line? Another vertical line. So I have to find out if this is a vertical line. I don't know. Or do I? Or do you? All right, so we're going to look at LM now. LM, we're going to do the same formula. Okay, what's y sub 2 in LM? 5. What's L sub 1? Negative 1. All right, great. What's x sub 2? 2. And x sub 1? Oh my, 6 over 0. What kind of slope is that? Undefined. Oh, you can't have two undefined lines, can you?
Yeah.
Two parallel lines that happen to be vertical lines. Is that possible? Okay, so the question is line JK parallel to line LM? Yes, they are parallel. They're undefined lines, undefined slope lines. So they're both vertical, and the vertical lines have to be parallel. Does that make sense? That vertical lines are parallel to each other? You guys good on that? Great. You're ready for this next one. The toughest one yet. These are going to be the hardest problems you're going to have on this lesson here. Okay, the instructions say, write an equation of a line that is parallel to 2x minus y equals 3 with a y-intercept of -5. Can somebody tell me what my definition of parallel lines was? Parallel lines have the... Sophie?
Have the
Same slope, but different y-intercepts. Okay, so you're like, how does that help me out? Well, can I find the slope of this line? Can I find the slope of that line? Go ahead and do that. Just find the slope of that line. However you do it. You can use standard form, slope-intercept form, but you find the slope of the first line here. And since you know standard form, you know it very quickly. Don't say it, but it's there. It's like hidden, just sitting there. Please find me. And I think most of you putting it y equals mx plus b form. Who's doing y equals mx plus b form? Okay, who's using standard form? Okay, so I think it's actually split, but I'll go slope-intercept form, and then let's see if we verify it. All right, so I'm going to subtract 2x from both sides. I get negative y equals negative 2x plus 3. Divide both sides by negative 1, which means everything gets divided by negative 1. I get y equals 2x plus minus 3. What's the slope? 2. Okay. It says write the equation of a line that is parallel to. Now, didn't they already give me an equation of a line? What are they asking for in this problem? Do you know what they're asking for? Another equation. So is this my answer? Did they just give me the answer and say, hey, write this equation out? No. They want a line that is parallel to this line, and it has a y-intercept of -5. Okay, so let's look at this equation right here. This is the one they gave me, right? This is what we call the given. Is this my answer? No. But it helps me to find the answer. You know my other equation is going to look like this. It's going to look like that. How do I know that the slope is going to be 2? How do I know the slope's already going to be 2? Because they're parallel. But remember what we said about parallel lines? They do have the same slope, but what about their y-intercepts? They have to be different. Oh, man. So how do you figure out the different y-intercept? Oh, it's right there. What is it? Done. That's what they gave you. You had to find the slope because you know the slopes are the same, and they gave you the y-intercepts. You know it's right here. Yes, ma'am?
Can you use a negative a over b?
Yeah, that's what I would have done. -2 over -1 is +2. Yep. So listen, now you have tools. Like some of you are like, I hate negative a over b. That's okay. Slope-intercept form is helpful. Oh, I love negative a over b. Great, use it. Right? Can you use it? Yeah, your choice. Okay, that's how you do this one. Did I say this was the hardest one? I'm sorry. That wasn't dramatic enough. I meant this one. Dun, dun, dun. So I should have said that was the hardest problem up to this point, and now this problem is the hardest problem up to this point. I want to find another line that is parallel to y equals -1/3 x plus 2 and passes through this particular point. That's really picky. What do you know about my other equation? You know what slope it's going to be, right? Yes, ma'am? Okay. So this is a slightly different process, but I hope you're going to get it. Okay, I need to find another equation. And I'm guessing it's going to be in this format. Okay, the y equals mx plus b. That's usually how you write your answers. But what's the slope going to be? Automatically, slope's going to be... Okay, so you already know you're going to have negative 1/3 x plus or minus something, right? I don't know what that b is. Is it 3 or 2? Is that my y-intercept? How do you know this is not your... This is thinking back. How do you know if this is a y-intercept or not?
Has a 0 in it.
X has to be 0. So is this my y-intercept? No. So what am I going to do here? We're going to go with... Ready? My favorite part of this lesson. We talked about standard form. We talked about slope-intercept form. Guess which one we haven't talked about? Point slope form. You're like, point slope. I already have a slope, and do I have a point? Yes. Point slope form. Y minus y sub 1 equals m times x minus x sub 1. We didn't forget about you, buddy. We're going to use all three in this lesson. Sorry, yes, and Josh too. Sorry, Josh. Welcome. Okay, do we know the slope?
Yeah,
Negative 1/3. Awesome. Oh, man, I don't know what x sub 1 and y sub 1 is, do I?
Yeah.
What is it?
Sub 1 is 3.
So, minus 3, and then y minus 2. Oh, look at that. But which form do I want it in? Dare I say it? This form. So, Miss Ray, do you remember lesson 5-5, guys, where I had to do point slope to standard, point slope to slope-intercept? Do you remember going back and forth? You know why I wanted you to do that? Because of this problem. You need to know how to do it. So can we get this into y equals mx plus b form? And the answer to that is absolutely. Okay, I'm just going to use distributive property right here. Ready? So y minus 2 equals, what's negative 1/3 times x?
1/3.
Negative 1/3 x. What's negative 1/3 times, negative 1/3 times negative 3 is?
1.
Positive 1. Positive 1. Is it in slope-intercept form yet? No. Oh, if I add 2 to both sides, I'm going to get y equals negative 1/3 x plus 3. That looks like an equation, doesn't it? What kind of equation is it?
Parallel to the...
Very nice, Sarah. It's parallel to this line, and it passes through which point? 3, 2. Now, I don't believe that. I think that's just me saying a bunch of stuff. I want you to graph this line right here. Graph this line, then you're going to graph that line. You may begin. Your graphs should maybe like a 4x4. I call them 4x4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. I guess you can technically call it an 8x8, but I call it a 4x4. 4x4 by 4x4. Maybe that's clear. Great question. So I'm going to graph the first line. I'll do it even in green, so we know which one we're talking about. By the way, I love these colors now. Okay, where do I start on that first given line?
Positive
1, 2. Positive 2. Ooh, that's nice. And then where do I go from there? What's the slope? Negative 1/3. So I go down 1. 1, 2, 3. Okay, and then I can also go up 1 over 3. And I have a line. Is it a perfect line? No, but it's a perfect line. That's a stretch, sorry. Okay, anyway. Let's graph the second line. And I'll do it in the same color as the original. Okay, where would I start the second line? 3. So 1, 2, 3. And the slope is the same. So down 1 over 3. Or up 1 over 3. Guess what kind of lines I have? Parallel lines. Now, remember, this is the line we came up with, right? So it's that tan color. Or blue now. Tan color. Okay. Does this line pass through 3, 2? So does this line right here pass through 3, 2? Let's see. 1, 2, 3. 1. Does it?
Yes.
So we fulfilled the requirements of that line. Do you see how that works? So it's not just like, hey, let's just use some formulas and hope we get something right. This line that we came up with is parallel to the green line, and it passes through 3, 2, which is what we wanted. You guys get that? Great. Swivel, goodbye.